This week's video is about Amazon Managed Service for Prometheus, AMP. I'd like to unbox that service for you that AWS announced at reInvent in December 2020, so we're catching up with all those announcements a little bit. What can you expect from this video? So first of all, I want to explain a little bit what Prometheus is all about, what can you do with it, what's its intention, what problems does it solve. Next, I will dive into what does AWS do with Prometheus. So how do they build a managed service out of that? Of course, I have a demo for you. I will show you how you can use Prometheus, the AMP service from AWS, to get metrics out of your container cluster and store them in AMP. And then we will dive a little bit deeper into the different features of the Amazon Managed Service for Prometheus. We will have a look at the limitations, have a look at the costs, compare it to other services, and so on. So let's get started. What is Prometheus? So it is a few things. So first of all, it is a monitoring system. So it is designed for either machine-centric monitoring, so that's what you know from the data center, from the on-premises world, but it's also built for a microservice architecture, for a service-oriented architecture where you have a lot of services interacting with each other. It allows you to collect metrics, it allows you to define alerts and get notified, for example, via email, PagerDuty, what have you. So it's a monitoring system. That's the first point. Second, Prometheus is also a time series database. So a time series database is optimized on the problem for storing time series data, which is a timestamp and a data point. And this is built into the Prometheus project as well. And as many other time series databases do, they have something in memory and then they write it on disk or even on colder storage later. So that's how they shard the data. So time series database, when I talk about that, I remember that we already have a video about Amazon TimeStream. This is also a time series database offering from AWS. It's more focused on more generic workloads. So it's, for example, for IoT scenarios, or Michael did a demo how you can import stock trades data into the time series database and then calculate all kind of interesting insights out of that. So if you haven't watched that, the video number 5 is what you definitely should have a look at. Okay, but back to Prometheus. So it is also a time series database. What else? Prometheus is a popular open source project. So it was originally built by SoundCloud, but it is a standalone open source project maintained not by a company, but really by the community. And it joined the Cloud Native Computing Foundation about 2 years ago. So it's really an open source project from the heart. So that is also, I think, important to know. And Prometheus is really popular in the Kubernetes ecosystem. So why is that? Because it's really well integrated. So those two work really well together. And it's no wonder that Prometheus was the second project that joined the Cloud Native Computing Foundation. So the first project was Kubernetes and the second one was Prometheus. So that's, you see already, those two really belong together. And now that we talked a little bit about what Prometheus is all about, let's have a look a little bit into the technical details, into the architecture. So the main part of Prometheus is the so-called Prometheus server. And there you have the time series database. So the time series database is really where Prometheus stores all the data. And then there is an HTTP server beside that allows you basically to access the data, for example, to send queries for the data, also to manage alerts and stuff like that. And then there's the retrieval part of the Prometheus server, because the initial idea is that the Prometheus server fetches the data, the metric data, from the systems that you want to monitor. So the idea is that there's a pull mechanism in place. So that's the default. That's how it works in combination with Kubernetes, by the way. That's what you can see in the architecture diagram as well. So with Kubernetes, Prometheus fetches the metric data from the Kubernetes API. It pulls the data in. And On the other side, sometimes you have use cases where it's not really applicable to for the server to pull for the data, and you want to have a push mechanism. And for that, there is something that Prometheus calls a push gateway. So this is a next or a separated service that you can use to provide an API to push data to your Prometheus server. And then how this works is it acts as a gateway. You can send your data there, and then the Prometheus server fetches the data from there, it pulls the data from there. So that's overall the design or the architecture of Prometheus. And one important functionality of Prometheus is also the alert manager. So this is where you can define thresholds for metrics, define who should be alerted in certain circumstances. You can have PagerDuty, email, or any third-party alerting system integrated with that. And then it is, in a common scenario, Prometheus is used together with another open source project, which is Grafana. Grafana is a tool that is popular to build monitoring dashboards, and it integrates very well with Prometheus because there's an integration for Prometheus, and you can then build dashboards out of that. So that's the whole architecture and interaction with other systems. So the Amazon Managed Service for Prometheus was announced, as I told you at the beginning, in December 2020 during reInvent. It is currently in public preview. That means this is not yet a production-ready service. It's in preview, which means AWS is collecting early feedback from customers that want to try out the service. It's not intended for production workload. That is really important. But it's a public preview. That is a little bit special because usually AWS is doing private previews. So you have to ask for an invite to such a preview usually. But in that case, Prometheus is doing a public preview. So that means everyone can join. You can just, with your AWS account, use the service. In the following demo, I want to show you how the Amazon Managed Service for Prometheus, AMP, works together with EKS, the Managed Service for Kubernetes. First, I want to show you the overall architecture. So most important, we have AMP, so the Amazon Managed Service for Prometheus. And this is where we will collect the metric data and where we will later be able to query the metric data, the monitoring data from our EKS cluster. But there is a special thing here. Unfortunately, AMP does not support pulling data. So when you remember the previous architecture diagram of Prometheus, I told you that the normal mode is that the Prometheus server pulls the data, for example, from the Kubernetes API. That's not supported yet by AMP, unfortunately. And that is why we have to provision a second Prometheus server inside our cluster. And this Prometheus server pulls the data from the Kubernetes API and then pushes that to AMP. So that's a little bit more complicated than it needs to be, but that's a limitation, at least of the public preview that we have right now. So hopefully that will change in the future, but that's how it works now. And by the way, the identity and access management service is used for authentication, authorization, and you need to sign your requests to AMP to get that working. So that's another thing that is important to mention. So now let's dive into the management console. Let's start in the AWS Management Console. As it is a public preview, you will find Prometheus, the managed service there. So let's jump into that. And there's not much that you can do here. So all you can do is you can create a workspace. And all you can configure is a workspace name. That's it. So really simple. So I've already done that. So there's a workspace named demo and it gets generated ID. And each AMP workspace has two endpoints, an endpoint for remote write, so to write your data, to push your data to, and a query endpoint. So that's all you need. That's all you get. That's all you have to configure here. Okay, so that's everything we have in here. Then I created an EKS cluster. And what is important to mention here, First, I tried it with Fargate, but unfortunately, this doesn't work. The reason for that is, as I told you, we need to deploy Prometheus server to the cluster as well, and that requires storage. It requires EBS volumes, and this is something that Fargate does not support yet. So my demo EKS cluster uses a managed node group, so spinning up EC2 instances at the end. So that's a limitation I have in here right now at the moment. Okay, so speaking about EKS, let's jump into the terminal and see what's going on in the cluster. First of all, let me show you what I have deployed into my cluster already. So get the services from the cluster. So what I've deployed is the Hello World example, the guestbook example from Kubernetes. So this is the front-end service, the Redis master and slave, and this is running in the cluster at the moment. And besides that, as I told you, you'd also need to deploy a Prometheus server to your cluster that fetches the data, that pulls the data from the Kubernetes API and pushes it to AMP. So that's what I have deployed as well. And I was following the AWS documentation to do so. You will find a link to that into the video details. So there's no way to have a look into your data with the AWS Management Console. But what I told you already is that Grafana is a popular way to build dashboards to visualize the data that is stored in Prometheus. And that's what I will do here as well. So a quick side note here, there will be a Grafana service by AWS as well in the future. This is currently in private preview and it's hard to get in. So what I've done as an alternative is I have deployed Grafana to my cluster as well. So back to the terminal, you see another service in here, and this is the Grafana service. And we will use that to basically look into the data. Okay, to do that, I need to do two things in the terminal. First, I need to fetch the password to log into Grafana, the admin password. And then next, I need to forward the local port to the cluster so that I can connect to it from my machine. So now I can go localhost 3000 and connect to Grafana running in the cluster. Okay, so let's log in here with the password that we retrieved. And so this is Grafana, and Grafana is where you can explore the metrics that are stored in your Prometheus database. So you can go here, you find a list of endless metrics, really metrics from the Kubernetes service all over the place. What I've done is I already created a dashboard, and to show you just this data shows the data out of AMP. So this was coming from the Kubernetes API through the Prometheus server running in the cluster and then pushed to AMP. And now Grafana fetches that data from AMP directly. So that's how this setup works. And you can see here the metrics that are coming in from my containers running in the cluster. So the setup works as expected. During setup, I didn't have too many issues. I was just following the documentation. I will put all the links that you need for that into the notes section of this video. So now you have seen AMP in action in combination with EKS. And next I want to dive a little bit into the details. So first of all, again, I mentioned that AMP is still in public preview. And what is support? That means it is available, but not yet production ready. So it's there for you to test if that will fulfill your requirements in the future, but it's not yet production ready. It's available in 5 regions. It is multi-ASAT by default, so distributed among multiple availability zones. It scales ingestion, storage, and querying automatically. So it's, from that perspective, it's really a serverless offering. You don't need to provision any CPU, memory, or storage capacities. That works out of the box. So this is cool. But there are a few limitations. First, we talked about that already. It's only pulling data is not yet supported. You have to push your metric data in, and that's actually not the default with Prometheus. So that is an interesting limitation. The monitoring part is not yet supported, so the alerting manager is not yet supported, so you cannot define any thresholds, alarms, anything like that. This is a feature that will probably come in later, but it's not available at the moment. And another important limitation is metric samples older than 1 hour are refused from being rejected. And by the way, also the retention period is 150 days. The data after that is deleted automatically. What's also missing is the Prometheus web UI. So really the management, AWS management console with creating or deleting a workspace is all we have at the moment. Besides that, we can only interact with the ingestion and query API. Yeah, we talked about the retention days of 150 days already. From a security perspective, I find it quite interesting that they're doing encryption at rest by default with KMS. Currently, you cannot configure your own CMKs, so your customer managed keys at the moment, but probably something that is on the roadmap. Data transit is HTTPS only, and by the way, only TLS 1.2 is supported, so clients must support that. Also, internal traffic between availability zones is encrypted with HTTPS as well. So that's, I think, good news. All the check marks there, can't find anything missing. Now let's talk about the costs. So the pricing model is subject to change as well. So this is the public preview. It's possible that AWS changes the pricing model, but we will have a look at what we currently have. And especially, I want to compare the pricing of AMP with CloudWatch, because that's what AMP is competing with on the AWS platform. So CloudWatch allows you to store custom metrics as well, so to push your own metrics to it. And AMP does so, and that's why I want to do a cost comparison. And to do so, I've created a spreadsheet. Let's have a look into that. Okay, so the idea is with that spreadsheet, we can play around a little bit with the numbers, because of course, the monthly cost depends on your scenario, on the workload that you want to bring in with CloudWatch, custom metrics, or with AMP. So let's compare that. So let's start. Let's say we have 100 metrics that we store. So I don't know, CPU for every container, memory for every container. A lot of metrics get created quickly. So let's start with a small one. Only 100 metrics that we need to store. And now the next question is, how many data points do we ingest per metric per hour? So I have set that to 60. So 1 data point per metric per minute. So that is what we have. Then the average data point size is important. So how much data do we need to store in our time series database actually? So AWS mentions an average of 2 bytes. So I'm just using that in here. I don't know, I might be more or less than that. It's not too important for the pricing. We can check that later. And then the next important thing is, how often do you query your metrics? So how much queries do you run per hour and per metric? And I've set that to 60 as well. So what we do is, for every metric, for every minute, we're doing a query, for example, to update a dashboard or to do alarms or something like that. Okay. Then what is also important is the average query processing time. So how long does it need for the query to process on AMP or on CloudWatch? I've set that to 100 milliseconds. That's hard to calculate up front, but that's just an average that I found in the AWS pricing examples. So I've used that. Okay, so now let's have a look into the results, and they are quite interesting. So here you see the total monthly costs, CloudWatch custom metrics compared to AMP. And what you can see here is AMP costs you around $1,000 per month, and CloudWatch custom metrics only about $100 per month. So this is a huge difference. And where does that come from? It comes from the costs for querying the data. With AMP, querying the data is much more expensive compared to doing that with CloudWatch metrics. Yeah, so let's play around with that numbers a little bit more. So let's say let's change a little bit the input values. So 100 metrics is not too many. So let's increase that a little bit. So maybe let's go to 1,000 once, and let's increase the queries that we do per metric per hour. So let's say maybe we only want to do it, let's say maybe only, I don't know, 10 times per hour. So now everything changes a little bit, because what you can see now is CloudWatch custom metrics are kind of expensive to ingest and also to store. So the prices compared from CloudWatch to AMP are quite impressive. Still, querying the data is much more expensive with AMP. So we're still in an area where we have where AMP is more expensive than CloudWatch, but the difference is not that much anymore. So let's increase the number of data points that we ingest. So example, let's double that. And now you see, things change quickly here, so it gets much more expensive. So let's say double that again. So now it gets, with the more data points that you need to ingest per metric per hour, the more expensive CloudWatch gets compared to AMP, because ingesting data is more expensive with CloudWatch than with AMP. So this is interesting. So let's go back to a scenario where you have very little, where you have, let's say moderate data ingestion and very little querying of that data. And now it's important. So what now gets important is now CloudWatch metrics is much more expensive than AMP, and that's because storing the metrics is also really expensive with CloudWatch. So what you can see here is, it really depends on your scenario. The pricing models between CloudWatch custom metrics and AMP is really different. So it can cost you 10 times as much to switch from CloudWatch custom metrics to AMP and otherwise. So really check your scenario, and it's really hard, I think, to calculate most of that up front, but really think about your workloads and choose wisely where to store your monitoring metrics. By the way, I will provide you the spreadsheet to calculate the pricing for AMP compared to CloudWatch custom metrics so that you can do your own math. You will find a link to that in the video notes. So last but not least, let's look into the future. So one interesting thing is that AWS is also working on a managed service for Grafana. And as this integrates very nicely with Prometheus and also CloudWatch, by the way, this is an interesting offering. Looking forward to that. And I expect AWS to implement pulling data from EKS and also CloudWatch into AMP out of the box. So I hope that integration will be there in the future so that you don't need those extra Prometheus servers as we do right now. And of course, I think we can expect AWS to implement all the missing features like the alerting manager, data retention, and so on. So this will probably be something that is maybe available when this goes into general availability, or will be delivered within the next 1 or 2 years. That's at least what I would expect. So I will definitely come back to AMP and do a review of the service, even more deeper dive into the technical details in the future. Stay tuned for that. So do you have any questions about Prometheus, about AMP? There is community.cloudonaut where you can ask all your questions. I'm happy to answer them. The community is happy to jump in and also start a discussion there. I'm looking forward to that. That's all from me for this week. Thanks a lot for watching. See you.